evaluating limits at infinity of radical function, you are given to evaluate the limit as x approaches infinity of root 4x squared plus x minus 2x all over x. How do you evaluate this? Remember, the first step is to recognize that its limit at either plus or minus infinity, then rationalize. Rationalizing implies we are going to multiply both sides by the conjugate in order to eliminate the root. So what we are going to have here will be the limit as x approaches infinity of root 4 x squared plus x minus 2x multiply its conjugate. Remember, conjugate is simply flipping the sign. If you have root a minus b, and the conjugate will give us root a plus b, provided it's in binomial form, meaning there are only two terms in the expression. So we are going to have 4x squared plus x now plus 2x, which is the conjugate, multiply by the conjugate. So we are multiplying the denominator by the conjugate, which is 4x squared plus x plus 2x. Now, what we did in the first example, if you haven't watched that, please go check out that video. The numerator can be written as difference of square, because if we have a minus b multiply a plus b, it can be written as difference of squares, which is a minus b square. And a minus b square, if we expand this will imply a square minus b square. We want to apply this to the expression here. So we are going to have the limit as x approaches infinity of now root 4x squared plus x minus 2x all squared all over x multiply root 4x squared plus x plus 2x. If we go further to evaluate, we are going to have the limit as x approaches infinity of, remember we are squaring each term, so if we square each term, look at what happens here. 4x squared plus x, the root of this is the same as this term to the power of 1 over 2. So minus 2x all squared. If we expand, we are going to have 2 over 2, right? And 2x squared, which will give us 4x squared. And you see 2 will cancel out 2 here. We are left with only 4x squared plus x. Now minus 4x squared. So if we apply that here, this will be the limit as x approach infinity of 4x squared plus x minus 4x squared all over what we have there, the denominator, x multiply the conjugate, which is 4x squared plus x plus 2x. We see 4x squared can cancel out, minus 4x squared. So we are left with the limit as x approaches infinity of x all over x multiply root of 4x squared plus x plus 2x. Now you see x already cancelled out x, right? So what we have left, so here x cancels out x. We have the limit as x approaches infinity of 1 all over root of 4x squared plus x plus 2x. If we go further in simplifying this expression, we are going to have the limit as x approaches infinity. Remember, the next step now is to factor out the highest power in the root. So we have 1 all over, the highest power there is x squared, so we factor that out. We have x squared multiply 1, that will give us, multiply 4, that will give us 4x squared plus 1, that will give us x squared multiply 1, that is x squared, but what we have here is x. So we are going to divide by x so that this radicand expression is balanced. Now plus 2x. We know that x squared root x squared is the same thing as x squared to the power of 1 over 2. If we expand, we have x to the power of 2 over 2, and 2 cancels out 2, and we have x left. So if we take this out here, what we have eventually is the limit as x approaches infinity of 1 all over root s squared will give us x multiply 4 plus 1 over x root 4 plus, now x is common here, so we just write 2 because x multiply 2 will give us 2x, so this is balanced. We can do direct substitution here as x approaches infinity. So as x approaches infinity, we are going to have 1 all over infinity multiply root 4 plus 1 over infinity plus 2, and this will give us 1 all over infinity multiply 1 all over infinity, it's 0. 4 plus 0 is 4, root 4 is 2, and the 2 plus 2 will give us 4. So what we have eventually is 1 all over infinity, because infinity multiply 4 will give us infinity. So we have 1 all over infinity, which is equal 0. This is the final answer. If you find this video helpful, please, we will appreciate if you subscribe to our channel, like the video, and share so that we are able to provide more content that will reach the larger community. Thank you for watching.